check to make sure we're recording. Yes, we are. All right, so then you just put, you've got gravity going down, got normal force going up, and then you have friction going like that. And notice they said not components, so don't break anything into components on that diagram. Yes. Huh? If you do, you will lose points. Follow the directions. When they say not components, don't break anything into components. Just leave the force. Okay, then calculate the force due to friction acting on the balls that roll on the roof. Huh? Yeah.
So when you draw the forces, it's okay for force of friction to be. Is it okay if you draw it from the center?
Nope. Because if the force of friction was from the center of the ball, then the ball wouldn't roll. Yeah. Because then there would be no torque. It would just be a retarding force through the center. So the ball would slow down, but it wouldn't roll. So if this was a block, that is exactly how you would draw it. And that's why they made this problem. To see if people would catch that. Yeah. I'm sorry? Oh, okay. So it's kind of like, what that means is there's a one-to-one correspondence between the circumference and the distance it travels. Right? Have you ever gone bowling? You know how like you can throw the ball and it spins? It's slipping while it's rolling. Do you see what I'm saying? Or like if you hit the gas and your tires go and you're moving slowly but you're burning out, they're slipping while you're rolling. See, but this is like a smooth, like controlled situation. And the reason that they say that is so that now I can associate with high alpha. Use alpha as T over R. If they're slipping, I can do that.
So, oh my god, now I have to look switch every day.
You mean like rolling friction?
Yeah.
Well, like you would say that the friction here is causing, and that's why she said the thing says it rolls without sliding, because then you would have to include sliding.
Okay, she went.
Decide right now.
So this is rolling. That is rolling. Okay, so here we go. So then what I'm doing is I'm making this like my axis, right? So I'm kind of shifting the problem and then saying that some of the forces parallel to the surface are equal to MA, and then I would say something like if I'm doing this, right? Obviously I'm not putting it on this drawing, I'm doing it somewhere else. See, you see what they said here? Do not add anything to figure in part A. Okay, so I guess I should do that if I'm telling you not to. So I'll say this is FG, and then I'll do this. So then this is mg cos theta, and this is mg sine theta. So then we have down the hill is mg sine theta minus f sub f is equal to ma. So basically it's down minus up equals ma. And I just use down minus up because down is winning. Winning. No.
Oh, that's so long ago.
Yeah, I know. That was like seems like a year ago. All right. Calculate the force due to friction. So then I just solve this for f sub f. So f sub f is going to be equal to mg sine theta minus ma. Okay. Now we don't know a. So. Wait, oh yeah, this problem I did this. So, how does A relate to rolling objects?
V over T.
Well, V over T is how you would define A, but how does acceleration relate to rolling or rotating objects? Alpha, right? A is related to alpha by saying A over R is alpha. That's the key. You can't do this without that. So now I say the sum of the torques is equal to I alpha. And then there's only one torque if I use the center of this sphere as my pivot. Right? If I use that as my pivot, then there's only one torque, which is F sub F times R, and then that equals I alpha.
Wait.
Now, yeah, go ahead.
So basically what we're looking for is actually the torque of the...
No, we're looking for F sub F.
Uh-huh.
And I got that equation right there.
Uh-huh.
But, do I know M? Yes. Do I know G? Do I know theta?
Yeah.
Do I know A?
Yeah.
No. So I have to figure out how to find A. So I sit and say, well, how am I supposed to find the acceleration? What's happening here? I have no other linear cause or course of action. But then hopefully it clicks in my head when I say, okay, wait a minute. I just need something outside of linear. Bing! It's rotational. What is this sphere doing? It's rolling. So then I say alpha. And then when I think of alpha, I should think of this. So basically, when you've got something that's rolling and sliding, and kind of translating, both things are going to be used. Just know that. Okay, then I, they tell me it's 2/5 mr squared, and then alpha is a over r. So that knocks out one r. This knocks out the other r. And over here, I get f sub f is equal to 2/5 ma. Or I could say a is equal to 5 f sub f over 2m. And now I can take that and plug it in there. Right, so that's going to give me f sub f is equal to mg sine theta minus 5 halves f sub f. And then when I move this over to here, I'm going to get 7 halves f sub f equals mg sine theta. And so f sub f is equal to 2/7 mg sine theta. Now, let's check and see if that's right.
Wrong. That's not.
Awesome, Rachel. Now tell me you're ready.
Oh, cool, yes.
Right on the forehead. Do not know.
Look what he's doing! What he's doing? I was supposed to do my work.
You don't get to do it.
You know what? Just pick up her hair and start sniffing it. See?
Good.
That's the reaction. Well, now she won't have that reaction. She'll just let you sniff it for goodness sake. So, let's see, when the girl does that, just pick her hair. And she'll be like, oh, I need a shower.
Rachel, you have more sweat than usual.
You don't know. Pick it for me. The split S.
All right. What are we doing? All right, we just did part B. Ugh. Okay. So then, for part C, calculate the linear speed of the center of mass of the ball when it reaches the edge of the roof. Remember, this thing's rotating and translating, so I just need to use some energy, right? And I would say something like PEI is equal to KER plus KE, whatever, just KE, linear translation, right? And so we have MGH is equal to 1/2 I omega squared plus 1/2 MV squared. And then, of course, MGH is equal to 1/2 2/5 MR squared V squared over R squared plus 1/2 MV squared.
Wait.
So then this mass cancels everywhere. This 2 cancels here. And I get GH, this R squared cancels there. I get GH is 1/5 V squared plus 1/2 V squared. So then that, of course, 1/5 is 0.2 and plus 0.5 is 0.7 V squared. So V is equal to the square root of GH over 0.7. So it's just a conservation of energy situation. This is so weird. They're doing a survey now. And then we have to have like an interview, exit interview at the end of the season to determine if my goals have been met. Yeah.
We didn't have goals this year?
Well, it's rotational and linear because it's not. Because it's rotating and translating. Sorry?
No, 20 times over.
Yeah, so it's because like this is translation and then this is rotation. So it's doing both things at the same time. Questions? I think it was C, right? Yeah, that was part C. So this should give us the linear speed. Once again, we'll go check, make sure that we have not butchered things too heavily. There's our 0.7. Yeah, there we go. Oh, the only difference being I just put H, but is everyone's aware H is d sine theta, right?
Yeah.
Oh, here's the kinematics solution. There you go, David. You like kinematics. So. And this one, and why does it work in this one? Yes, there you go. Okay.
So basically, what you have to remember is that like rotation is the rotational equation, like the rotational energy equation, and then that's
Well, it's the linear plus the rotation. Because it's moving in two different ways. So we have to include both methods of motion.
Okay, hostile, bro.
All right. So then we go back and look at part D. A wagon containing a box is at rest on the ground below that falls vertically, blah, blah, blah. Total mass of the wagon and the box is blah, blah, blah. Calculate the horizontal speed. Okay, so we don't care. Like, this is going to have some velocity like this. And then I don't care about vertical at all. It doesn't matter. So we just care about Vx. And then it's just Pi equals Pf. So it's going to be, just kidding, mass of the ball, velocity x, right, equals mass of the ball plus mass of the cart times V final. So V final is just going to equal MBVX over MB plus MC. Right? It's just an inelastic collision.
inelastic collision basically means that they just add together.
They stick. The two things stick together. Yeah. Elastic bounces, inelastic sticks. Okay, questions?
Mass of the car and mass of the ball, and then
All right.